Welcome back everyone. Today we are going to talk about random forest. So far we have seen decision trees, but now let's see when we have different types of multiple trees in our one single problem and all of them have to contribute in finding our solution. So random forest is something which looks like this in front of you. So they are an ensemble classifier that consists of many decision trees and outputs the class, that is the mode of the class's output, by individual trees. So here you see all the individual trees are contributing in finding the final solution. Each of them opts out the result that their particular tree pops out, and ultimately by majority voting or averaging, all the individual results are taken into consideration to find the final solution. So let's see a little bit background of random forest. So this term came from random decision forest that was first proposed by Kamhoff Bell Labs in 1995. The method combines Bryman's bagging idea and the random selection of features. And how does it work? Let's see. We have a training set and we take out one bag from it. For example, it has random selected rows from the training set. And similarly, we have another bag which has randomly selected in different type of manner of the rows from the initial set. And we have now two different trees in front of you. So if we try to create a random forest recursive decision making method, this is how it will look. So we have different attributes as we saw in the decision tree lecture. Similarly, we have a different type of decision tree which has a refund attribute on the top, and we have here three different types of trees, possible trees that were constructed from one simple same example, and all of them will have different types of solutions now based on how the problem is traversed in them, and all of them will have a different answer of a class. For example, our first tree on the left will give us a certain name of the class that particular tree will pop out, and similarly all of them will have their individual answers, but by majority voting we will have a final class which is our solution. So let's see features and advantages. So it is one of the most accurate learning algorithm available. For many data sets, it produces a highly accurate classifier. Multiple decision trees are contributing in finding the final answer. So we can say it is closer to accuracy, and it's like most likely we will not miss any branch or any single option to find out the solution. But it runs efficiently on larger data sets. It can handle thousands of input variables without variable deletion, and it gives estimate of what variables are important in the classification. It generates an internal unbiased estimate of generalization error as the forest building progress. It has an effective method for estimating missing data and maintains accuracy when a large proportion of data are missing. However, it has some disadvantages as well. Random forests have been observed to overfit for some data set with noisy classification for regression tasks. And just a brief intro, what is overfitting? Works well on training data, but it does not generalize. For data including categorical variables with different number of levels, random forests are biased in favor of those attributes with more levels. These are the few disadvantages for random forest. That's it for today. Thank you.